Hello and welcome to lesson 6 in the topic of resources and energy resource management. This is the second lesson that's focusing on energy resources specifically. So last lesson we looked at renewable and non-renewable energy resources, and we'll do a quick recap of that as well as going on to today's lesson where we are going to be looking at the energy mix. So by the end of this session you should know what the term energy mix means. You should have an idea with some examples of some of the UK's energy mix, but also a couple of other places around the world, so Iceland and India specifically. And also you should be able to identify why, so reasons why the energy mix of different places varies. So that's quite a lot to get through again today. So write today's title and learning objectives down while you pause the screen. When you're ready, unpause the screen and we'll do a recap of renewable and non-renewable energy to kick us off. Okay, so here we go. All you need to do is look at the following images on the next slide and just say whether it's renewable or non-renewable. Don't need to write anything down, just look at the image, and this again should be absolute bread and butter for you. Here we go. Okay, you should be shouting at the screen renewable, and if you want you can add the fact that it's wind. Okay, so wind turbines, they're wind farms, renewable energy. Right, okay, hopefully you got the idea. Next one. Okay, non-renewable, and it's coal. That's renewable solar energy. This is renewable, it's geothermal energy. This represents oil, which is non-renewable, and you could argue gas as well. This is renewable and it's hydroelectric power. Right, okay, so let's get a definition down because again, we love a definition in geography. What is the energy mix? Well, it's where countries use different energy resources in varying proportions to meet demand. So write down that definition and then I'll talk you through and break that down a little bit. So when it comes to the energy mix, what it means is that effectively no single country just uses one thing for their energy. There's not one place in the world that says, right, the only way we're going to get energy is from coal. We're going to burn coal, that's it. 100% of our energy comes from coal. It's not the case. Every country has a range of energy generating means. So, for example, the UK will use some coal. We'll also use some gas. We will use oil. We will use wind. We'll use solar. So there's a wide range of different energy resources which all kind of pull together to produce the energy that we can consume in the country as consumers. So the energy mix is just the different proportions. So because some countries, for example, we're going to focus on Iceland a bit later on as well, but Iceland have a lot of their energy from geothermal resources, and that means heat from the earth, so because effectively they're a tectonic region of the world, whereas the UK has very little, in fact none, from geothermal sources because we're not. So Iceland's energy mix is dominated by geothermal power, and it's also got a lot of water, and therefore they use a lot of hydroelectric power. So Iceland's got hydro, geothermal, but also they can't get away with not having a bit of oil because people drive and things like that, and oil is responsible for petrol engines, for example. So Iceland has a bit of a mix, but the mix is maybe different or more limited because they have certain resources available. But there are other reasons why that's the case too. So the energy mix is just the different energy resources in terms of their proportions in each country and how they vary. So you're going to find out today why different countries have different energy mixes. You need to know specifically about the UK's energy mix. You need to know that off by heart really, and you also need to be able to refer to other countries, and we're going to look at India and Iceland because they're a nice contrast. So the global energy mix, if we look at the world as a whole, and again it's not always useful because there's so much variation, but let's give you that general picture. In Office 365 in the job logs folder there's a graph, and the graph is going to be useful for the next bit. So in terms of the global energy mix, non-renewable sources hover, but they vary, but they're about 80% of the total energy resources, or they have been. Now, we all should be able to see whether this stat is correct because we're actually a year past this date now, but they think and they've estimated that by 2020, which was last year, the resources or use of non-renewable resources could drop to approximately 76%. And we are actually seeing that trend. It is happening, but it needs to be done more. And again, for various reasons, we've just experienced or North America have just experienced record temperatures, which have been an ongoing trend. But the record temperatures that they've experienced in parts of North America haven't just gone up by like 1 or 2 degrees, it's by like 5 degrees. It's insane, the level of rise that's increased, and it's baffling climatologists around the world, and it's maybe making them more concerned about climate change patterns. And that's why non-renewable resources need to drop by probably more significantly than up to 76%. We need to be looking at well below 50% if we're got any hope. So this graph, it's called an area graph. This shows you world energy consumption, so the amount of energy that's used from different sources. It's not got all of them on there, it's kind of lumped a few together, but if I could talk you through this graph, I would, and I will. I'm just going to give you a chance to try and interpret it yourself first. So get this graph from Office 365 or from this screenshot it and put it into your notes, and answer those 3 questions if you can, please. Pause the screen while you do it, and then I'll reveal the answers. So the first question says estimate. Estimate the difference in total energy consumption between 1965 and 2010. Now, interpreting these graphs always throws students off a little bit because they're not quite sure what they're seeing. What you've got here really is a series of line graphs, but those line graphs effectively kind of build up to give you an overall picture. So this line here, the very top line, okay, which I know just looks like oil, but the very top line is all of the resources added together, because oil is only this tiny proportion. So in 1965, only this much oil was being used. The biggest energy source in 1965 was coal. Then gas was another one, and hydroelectricity was another one, and maybe a fraction of nuclear power. So all of these different energy resources, the nuclear plus the hydro plus the natural gas plus the coal plus the oil, they contributed to the overall energy consumption. So around about sort of, 1,500 million tons of oil equivalent, MTOE, in 1965, and then in 2010 it was around 4,000. So 4,000 minus 1,500 means that it's approximately, the estimated difference in the total energy consumption is that it's changed by about 2,500 millions of tons of oil equivalent. Okay, so that is how these graphs work. They're like a compound line graph, we'd call it. Sorry, not a block one. So estimate the percentage of fossil fuels used in 2000. You need to look at this year specifically. Okay, and then you need to know which of these is a fossil fuel. And for the purposes of this, we're going to just discount nuclear. Just let's not call it a fossil fuel. And then I want you to try and estimate how much of the total, okay, of 2000. So 2000 is about 3,500 million tons of oil equivalent, or billion tons, I should say. How much of this total kind of compound area is fossil fuels? Okay, so have a little go. Take your time to do it. Now I've explained the graph. Hopefully it should help a little bit. Okay, so again, it's an estimate. I'll put the lines on there. It'll help. That's the total for 2000. So the total is about 3,500 MTOE. And the fossil fuels, I'm just going to count as oil, coal, and natural gas. So the blue, the red, the green. So the blue and the red, the green make up about 2,900 MTOE. Okay, the rest of it, this little chunk here, from renewables, nuclear, and hydro, we're not going to count. So again, approximately, if yours is near enough that, then great, well done. It'll still count because it's an estimate. And then last question, describe the change in global energy consumption. So we've talked about describing changes in terms of line graphs. So try and tell me what's happening, what's the overall trend, are there any anomalies, is there any data you can quote, that sort of stuff. Okay, so there you go, 83%. I should have done the percentage bit for you. Sorry, that's how I worked the 83% out. So, this is the answer to question 3. So again, we did the PDA technique a couple of lessons ago, pattern data anomalies. I'd like you to, hopefully you practice that using this particular thing. Overall, there's been an increase that you should have mentioned. That's the pattern from 65 to 2010. It's risen by 2,500 million tons of oil equivalent, or MTOE, from 1,500 to 4,000. So that's using data, pattern data. Fossil fuels dominate, making 83% of global energy consumption in 2000. Now, you should have identified, really, that I used the first and second question in my answer, because why not? I've actually done the maths already. The overall pattern is that it's going up by this much, and in 2000, I've picked one year, 83% was fossil fuels. However, bit of an anomaly here, the use of renewables has been on the increase since 1990. Here they come. So that is describing the changes to global energy consumption. It's going up from this to this. In 2000, I could have picked any year, but I picked the year 2000. 83% of fossil fuels dominated, but renewables are growing. There we go. Pattern, data, anomalies, all shown and demonstrated through this particular graph. All right. So, exam skills done again. Again, if you want to pause the screen just to digest that and take some notes, then I'd recommend it every time. You're always going to be assessed during exam. Using an exam. But we're going to now start to look at the energy mix for specific places. So, this is the UK's energy mix in 2014. It's just the nearest kind of donut graph I've got from the book. So it's quite old now. It's 7 years old by the time of me recording this. But the composition of the energy mix hasn't changed loads in this time, but it certainly will. And this is only 1 year. So get this graph from the either from a screenshot or from the Joglogs folder, and get it into your book, and we're going to annotate it. So, I've given you a bit of true or false statements here, and you can annotate it once you've worked out whether the answer is true or false. So the first one, it says coal makes up the UK's largest source of energy at 34.1%. Let's have a look. Coal is 16.4%. So that's wrong. That's false. So if I know that that's false, there's no point annotating my thing with a wrong stat. But what is the right answer here? What does make up the UK's largest source of energy at 34.1%? It's gas. So now I can annotate my graph by saying gas makes up the UK's largest source of energy at 34.1%. So on my graph here, okay, I'm going to put a little line around it at the space in my book, and I'm going to say gas makes up the largest at 34.1% in 2014. So I'm basically giving you the annotations, but it's not as easy as just writing them down. Don't just copy this out. What I want you to do is read it, look at the graph, work out if it's true or false. If it's true, just write it down. If it's false, correct it, then write it down. Hopefully that makes sense. So you would write gas makes up the UK's largest source of energy, and the next one, the UK relies heavily on non-renewable energy resources, 84.5% of them. You're going to have to do a little bit of maths here to work out whether that's right or wrong. When you've worked it out, correct it or not, and then write it around your graph. Pause the screen, do that, and then I will go through the answers. Okay, so number 2, that is true. That was just a standard one to write down, annotate around your graph. Number 3 is false. It's actually 68.1%. So you can, again, annotate your graph with this information. Just change 60% to 68.1%. Number 4, that's false. There's actually a decrease. But the graph doesn't show you that because the graph only shows you 1 year. So if you got a bit confused there, then that's fine. That's not a problem. This was just a case of me just providing a bit of extra information. So please do annotate the graph with this information, but it doesn't really point anywhere. Number 5, that is true. The largest renewables in the UK are wind and bioenergy. Again, not necessarily sure you'd get that from the graph. And the UK has an overall target of 15% of energy generation. Again, I don't expect you to know this. I'm hoping some of you looked it up on Google, but it is true. So again, you can add that. Because the bottom 3, really are just extra information for your notes in your book that tell you about the UK's energy mix. Should you be given a question on an exam, you know that if it says, describe the pattern of the UK's energy mix over time, you can say, well, the UK's energy mix is still dominated by non-renewable energy, but it is increasing its proportion of renewables. That information is in your notes now, so you can draw from that in an answer in an exam. So pause the screen, get all the information written down, and when you're ready, unpause, and we'll then start to look at a couple of other places. All right, so the world generally does rely on non-renewable energy resources, and we're going to start to explore kind of other energy mixes around the world to help us explain this. But there is a YouTube video which is also pretty decent, which you can watch. So again, the video may well be saved on 365. If it's not, just type this YouTube link into Google or into YouTube, because you're on YouTube currently, and watch the video, please. Once you've done that, we'll then start to crack on with variations in energy mix. So this can be another subtitle here, so subheading, variations in energy mix. And we're going to start to think of factors that why energy mix varies. I've already kind of mentioned one. At the start of this session, I talked about Iceland and why Iceland have lots of geothermal energy. But can you think of any other reasons which would affect what energy resources certain countries use? Think about that for a minute, and then we're going to go through some and write some down. Okay, so one of the things that it might include is how wealthy the country is. The UK is a wealthy nation, we're a developed country, so as a result of that, we have the money to invest in developing wind. It costs money to research and develop wind technology, and if you want to get the most out of it, you're going to need to spend money on developing it and making sure it works and building the infrastructure there, building the power stations that can manage energy. Nuclear power stations cost billions to build. So if you're wealthy, you have the ability to have a wider energy mix, and the UK does have fairly wide energy mix. The government and international policies. If the UK government want to stick to their climate agreement targets and environmental concerns, they absolutely need to reduce their reliance on non-renewable energies. So they've already said that they want to try and stop people being able to buy new gas boilers past 2025. That's really soon. And actually, unfortunately, there's not the power or the funding in place to develop the non-renewable sources. So there's things called ground source heat pumps, which are renewable boiler sort of solutions, but they cost like £15,000 or more, whereas a new boiler can cost you £2,000. So it's a big difference between the two, and that's something which the UK government are basically tied to. They've said, we will commit to doing this. So if your government have got a policy and an environmental concern they want to kind of help contribute, then it will affect the type of energy mix they have. How big your country is. Populations like India are, the second largest, will soon be the largest on the planet alongside China, which means there's lots of people that want energy. Those people don't want to wait around for you to develop renewable energy. They want it now. So they want lots of energy, they want it now. And as they're developing, getting wealthier, that demand only increases, especially in terms of its rapidity. So if India have got coal available and they've got the power stations available, they're going to want to make sure they utilise those to provide their population with enough energy. It doesn't mean they're going to ignore renewables completely. It just means that their population size and the demand for energy dictates how much they can invest in those other energy resources. And we've talked about this one. This is the one we mentioned about Iceland. Is it available? The UK can want to have geothermal power as much as they like, but it's not as easy for them as it is Iceland, who have active volcanoes and have got waterfalls that can generate huge amounts of energy through things like hydroelectric power and large amounts of rivers, etc. So all of these factors are at play when it comes to determining a country's energy mix. And again, you need to actually have a couple of examples to refer to that aren't just the UK. So we're going to look at those. Here we go, 2 pie charts. And again, worth having these pie charts. The one on the left is India, and the one on the right is Iceland. Now again, these are very basic. They don't cover everything, but they are there for us to compare. So to contrast India and Iceland's energy mix, we can say Iceland's got more renewables because if you look at Iceland, it's got geothermal and hydroelectric, which make up more than 3/4 of their energy use. Whereas you look at India, coal and oil make up more than 3/4. So as much of India's energy mix is non-renewable as Iceland's is renewable. Okay, varying proportions. India also, however, has a wider energy mix, so they use more non-renewable. Iceland's energy sources are geothermal. India's coal. India uses coal, nuclear, gas in its energy mix, but Iceland doesn't have coal, nuclear, or gas. The reason for that, again, we'll go into in a bit, but this is just about comparing, just about saying what you see. You, again, need to be able to know Iceland and India's energy mix as well as the UK's because, and I'll tell you why, there was an 8-mark question in an exam where it asked you about energy mixes and why they vary. But it also specifically said you need to talk about the UK and other countries. If you didn't specifically mention other countries, you didn't get full marks. So it was all about the reasons why energy mixes vary, but using examples of places like the UK, India, and Iceland. So you have to know some of the stats. So it's really, really important that you get this stuff written down. Now, in terms of reasons and mixing the stats with the reasons, this information on the screen will help you. I believe this is available as a ready-made card sort on 365 in the Job Logs folder, but again, you can always screen print what's on the screen now, but you need to match it up properly. So the 3 areas I would say, the 3 kind of main reasons I would filter your information into is about what determines an energy mix in a country is firstly population, how many people, how much money you've got, and is the energy available there. This slide really is almost like all you'd need for an 8-mark question on this, except it doesn't include the UK. You'd need to maybe mention the UK too. So with regards to population, income and wealth, and energy availability, you need to match these up and read through these notes, highlight the stats and the numbers that you've got there, because they would be vital for building a really good paragraph for an 8-mark question. So pause the screen, read them through, match them up, and just make sure your notes have got these in and you're reading through them properly. Okay, so population, income and wealth, and energy availability are all listed there specifically on the screen. So now we've got a good basis for not just specific countries, but also reasons why energy mixes vary. And to sort of summarise the lesson, I want you to, you can do this if you'd like, there's not a huge value in this, but what I would say is to summarise the lesson, you've got a definition of what energy mix is. You've got 3 countries, the UK, Iceland, India, where you've got specific examples, which I would like you to try and remember as much as you possibly can. But also the key thing and the most important part of today's lesson is that you identify the reasons why energy mixes vary from country to country. So think about the population size, think about the wealth, think about how available the energy is when it comes to maybe looking at exam questions, because these are going to be the business end of the exam paper when it comes to the energy topic. So you really need to make sure you brush up on these skills. Alright, well done. Thank you very much for listening. Again, another massive set of notes for your book. It is a shorter topic in terms of number of lessons, but I would say in terms of the note taking, this really is one of the most challenging topics. So going through and filtering that information regularly is going to be key. So thank you very much. I'll see you next time for lesson 7 of energy resource management. Thanks again.